Hello Year 9s. I hope you coped okay with the end of topic test on energy, and I will be looking at that in the next few days to see how you did. In the meantime, we've got some work for you to get started on this week, which is the beginning of the next topic. We're going to be looking at properties of materials, and we're going to start off with looking at density. So, density is something that you would have covered perhaps in Year 8. I'm going to look at it in a bit more detail perhaps this year and make sure you understand what it is and how we measure it. So density is a property of a material. It is basically how much mass is contained in a unit volume of a material. And to illustrate this, we've basically got some different materials here. We've got some ceramic, we've got some wood, and we've got some aluminium. And we're going to show you experimentally in this little video how you would measure the density of a material. There's also going to be some notes for you to take down, and there's also going to be some homework for you to do for this week. So it shouldn't be more than an hour or two's work for you to do, but obviously we need to get that in by the end of the week. Okay, so density then is, you'd work it out if you've got the mass of a material and you've got the volume of a material, and you divide mass over volume, you get the density of a material. The unit for density, well, the standard unit in physics would be kilograms per cubic metre, because mass is normally measured in kilograms and volume is measured in metres cubed. So kilograms per metre cubed would be the standard unit of density in physics. Quite often, just for convenience, we often use a different unit for density, which is grams per cubic centimetre. Usually because when we're measuring things in the lab, most objects come in sizes that we can measure the mass in grams and the volume in centimetres cubed, rather than kilograms and metres cubed. But as I'll show you, it is quite easy to convert between the two. So just to begin with, I'm just going to show you these two materials here, the wood and the aluminium, just to demonstrate to you what we mean by density. Now here we've got some mass scales. Now the interesting thing about these two blocks is they're identical in terms of volume. Okay, they're exactly the same volume. We'll show you in a minute how you'd measure the volume. But if we put them on the mass scales, you'll see something straight away. Put the aluminium on, 161 grams. Put the wood on, 33 grams. So despite the fact that they're the same volume, they are very different in terms of mass. So the aluminium is much more dense than the wood. In fact, if you were to put these two in water, the aluminium would sink and the wood would float. Now, in terms of calculating the density of these two objects, what you would need to do is measure the mass, which we've just done on the scales. So we had, what, 161 grams and 33 grams. So you'd measure the mass on the scales, but you'd also measure the volume. Now, because these objects are regular, they're cuboids, what you can do is just measure their dimensions and then calculate what the volume is. So in this case, you could just use a ruler. If you're doing it more accurately, there are instruments that are more accurate than rulers, such as calipers or screw gauges that could measure sizes. But we're going to use a ruler to do it. So let's just look at this accurately. I'll turn the ruler around so the scale is correct. So here we've got 5 centimeters long. You can do that on the other side if you like to show it's more accurate. There we go. So 5 centimeters long. The width is 4 centimeters or 40 millimeters, and the height is 3 centimeters, 30 millimeters. So if we do 3 times 4 times 5, that gives us 60 centimeters squared. So the volume of this is 60 centimeters squared. The mass was 161 grams. Now we could do the same thing with the wood, but we don't need to because we know it's the same size as the aluminium. So both of these have a volume of 60 centimetres cubed. So what we do now, if we wanted to work out the density, we go over to our calculator, and if we want to do the, let's do the aluminium first. If we want to do the aluminium, 161 divided by 60, convert that into a decimal, there we go, 2 points to nearest decimal place, 2.7 grams per cubic centimetre. So that's saying that every cubic centimetre of aluminium has a mass of 2.7 grams. If we wanted to convert that into kilograms per cubic metre, we'd multiply it by 1,000. So 2,700 kilograms per cubic metre for aluminium. So that's how you work out density for a regular object. You can measure the volume using a ruler, and then you just do mass divided by volume on your calculator. So if I do it for the wood, 33 divided by 60, so that's 0.55 grams per cubic centimetre. So you can see the density of wood is a lot less. Now the density of water is 1 gram per cubic centimetre. In fact, I can prove that to you here, because what I've got is I've got a beaker of water, and if I just show you on the scale there, we should have 150, it's not focusing very well, but 150 centimetres cubed of water. Now the mass of that water should be 150 grams. Now we can prove that if we take an empty beaker, put it on the scales, and then what I'm going to do is zero the scales. Okay, so that's then taking off the mass of the beaker. So when I take it off, it is going to go negative. Then if I put this on, we should get something close to 150. There we go. In fact, exactly 150. So that's how you'd measure the density of a liquid. You'd measure the volume in a measuring cylinder or a measuring beaker like this, and then you'd do the mass. You'd have to subtract the mass of the empty beaker. So you've got 150 grams, 150 cubic centimetres. One divided by the other is 1 gram per cubic centimetre. Now, as I said before, if I was to put this in, the aluminium, it would sink. If I was to put the wood in, it would float, because the wood had a lower density, the aluminium had a higher density. Okay, so that's how you'd measure. We've seen how you'd measure the density of a regular object, such as the aluminium and wood here. We've seen how you'd measure the density of a liquid, and that's fairly straightforward. The one thing that you might be asked to do is to explain how you'd measure the density of an irregular object. Now, as an example of an irregular object, I've just picked this out of my garden. It's an old piece of broken pottery. Okay, so a bit of ceramic. How would I measure the density of this? Well, I'd measure the mass quite easily. I'll show you what the mass is. So if I stick this on here, so we've got 54 grams. Okay, so that's the mass of this piece of ceramic. If I wanted to measure the volume of this, I couldn't just measure it with a ruler, because it's not a regular object. It's obviously irregular. So what I would have to do is use something called the displacement method. Now, a displacement method basically entails putting this in a liquid, usually water. And as long as it sinks in the liquid, it will completely displace its own volume of the liquid. So I'm going to demonstrate this with the beaker of liquid here. So let me just sit down. So at the moment it's reading 150 centimetres cubed on the volume on here, and if I submerge this, it has to be submerged completely, you can see how it's gone up to 175. So that would be 175 minus 150. So the volume has gone up by 25 centimetres cubed. So the volume is 25 centimetres cubed of the piece of porcelain. Now, to be honest, this is a measuring beaker. If you're doing this accurately, I haven't got all my equipment from the lab at home. If you're doing it accurately, you would probably use a measuring cylinder that had a finer scale on here, and you'd be able to get it a bit more accurately. The other thing that you might use as well is something called a Eureka can, which is a specially designed can which has a spout on the side. And what you do with that is that you fill up the water to the level of the spout, you put your object in, and then the water overflows through the spout, and then you catch the water in a measuring beaker or a measuring cylinder, and that you measure the volume of water that's been displaced through the spout, and that's how you would do it. So that's measuring the density of a irregular object. So let's just see if we can actually work out what the density of this porcelain is. Now I can't remember actually what the mass was, so I'll just measure the mass again very quickly. So here we go. That's right, 54 grams. So I go back to my calculator. So I'm expecting it to be bigger than 1 because it did sink. So 54 divided by 25, and the answer, there we go, 2.16 grams per cubic centimetre. So that's probably about right. Rock's normally about 3 grams per cubic centimetre. Of course, this isn't really rock. It's made of clay, isn't it? It's porcelain. So hopefully you understand how you would measure the density of a material. And remember, density is a property of a material. It's not a property of the amount of a material. It doesn't matter if you've got a piece of aluminium that's the size of a house, or a piece of aluminium that's the size of a grain of salt. It would still have the same density, because it's how many grams are packed in each centimetre cubed. And for aluminium, it's always 2.7 grams per cubic centimetre. It's a property of the material. So density is an important property to use in physics. The formula that links density, volume and mass is density equals mass divided by volume. You may have to turn that around. It's a triangular formula. Okay, that's it. I hope you understand that, and if you have any questions about it, don't hesitate to send me an email and ask me, and I'll do my best to help. Thank you.